All right, so one more good parametric equation problem today. If I just make this up, this gets a little tricky, but I'm doing it. I'm making this up. I'm sorry. Is this live on camera? All right, I made up this is crazy. This is a set of parametric equations. Nobody knows what it looks like. I don't know what this is. It's kind of weird, dude. X is a t squared kind of thing. Y is a t cubed kind of thing. You know, when we wanted to see what it looked like, do you remember the technique we would use to see what it looked like? Well, you type it in your graphic calculator. I mean, that's one way. But before we knew about graphic calculators, we would try to eliminate the parameter, and maybe we'd say, oh, it's just a line, or it's, oh, after you eliminate the parameter, it's a circle, or, well, guess what? You don't always can do that. I mean, you can't always do that too easily. I mean, can you imagine trying to solve for t and then plug it in here to eliminate the parameter? I mean, you get some crazy x to the 3/2, or I don't know. It'd be, or, yeah. So anyway, we can't. We're not going to eliminate the parameter. So we're going to pick up our graphing calculator and graph this. But before we do, I want the derivative. So that's easy. The derivative. So it's called dy dx, and we've been practicing it. So how do you do the derivative dy dx? You do dy dt. So again, you're kind of tempted to put him up, but it's this guy first. Dy dt, 3t squared minus 9.
Okay.
All over
4t plus 4.
4t plus 4. Okay, that's cool. Now, I got some questions for you. Here we go. Part A. When is dy dx equal to 0?
When the numerator is 0.
So when is the derivative 0, right? Is that what I'm asking? Mm-hmm. And so she said when the numerator is 0, that won't be too hard. Let's work on that. 3t squared minus 9 equals 0. I'm sorry. Move the 9 over. 3t squared equals 9. Divide by 3. T squared is 3. What's t? Oh, plus and minus. Plus or minus the square root of 3. Woohoo! So okay, good. We found it. When is the derivative 0? At those times. Plus and minus the square root of 3. Cool. That's easy. It's good old cow 1 kind of stuff. All right, except we're in parametric equations. So I made up this crazy parametric equation. We took the derivative. It was easy. Dy dt over dx dt. And now I asked you this. When is the derivative 0? So that's cool. That's easy. Now, watch this funny question. Where is this? So I asked you when. So again, to me the word when is looking for the t, if we're pretending t is time. But now I'm asking for where, which is looking for a location. What do you think I should do?
Plug that into.
Yeah, plug that into.
Plug that into.
Derivative.
Or your.
Not the derivative, but to find the actual location where this is, I can plot points and get an x and a y coordinate for this t, or for both these t's. And it's kind of a pain because they're nasty. I'm sorry.
Yeah.
Can you help me though? Even though it's a pain. So when t is the square root of 3, I want to find that location. I want to plug that in for x. I get 3. For x, I get 3 plus 4 square roots of 3. You could help me with it. It's some kind of decimal, but that's what I just got. And if I plug the square root of 3 in here, I get I get negative 6 square roots of 3 plus 18, I think. I'm just plugging square root of 3 in, dude. Doing my thing. It'd be nice if we kind of knew it better. I mean, this is exact. Roughly, that's 9.8. 9.9.
Are we still plugging in square root of 3?
Well, yeah. You're plugging square root of 3 into the y value now. I did it already, I think. But I'm going to trust you when you say what? 7.6. You guys trust her? I appreciate your help on this. Now, listen, that's one of the locations. Where's the other location? When t is the negative square root of 3, let's find it. When t is the negative square root of 3, that's, I'm plugging in a negative square root of 3. I get 3 minus 4 square roots of 3 is what I get. And then when I plug in a negative square root of 3 in here, yeah, I get positive 6 square roots of 3 plus 18, I think. I'd appreciate you guys helping me, but anyway, can you go ahead and decimalize that?
Negative 3.9.
Thank you.
36.6.
Thank you. Now, hopefully I did that all right. I got 25 people double checking me, right?
For 6 square roots of 3 plus 18, I got 28.4.
Yeah, that's what I got too.
But first of all, am I even right? Was that right?
Was anything right?
Yeah, isn't anything right?
You're right. The devil.
I think I did these quickly in my head, so I'm hoping they're right. And then if you trust me, you'll give me these decimals, and I'm trusting you.
9.9.
But you get my question? When does this happen? And now where does this happen? You with me? These are locations. Now here's another question. I got when, where, how about this?
How high?
Why? I mean, why is the derivative 0? What's happening on a graph that makes the derivative 0? What's going on?
Slope is 0.
Good, the slope is 0. Now, can you say that another way? A more geometric way.
The tangent line?
There's a horizontal tangent line. That's what I'm kind of looking for. That's what's happening here, you guys. We should have a horizontal tangent line at these places, a place where the slope is 0. Some students, when I write this, they write down horizontal asymptote. No. They're just getting the word horizontal wrong. Horizontal tangent line, right, when the slope is 0. Cool. All right, I'm sorry. I'm not sorry. Part B. Question B.
Oh, this was all A?
Question B. When is dy dx undefined? So now this is easier. This will go quicker.
When t is negative.
When x is equal to 0. Yeah.
Wait a minute. When is the derivative
Undefined.
undefined? And it's going to be the derivative's undefined when the denominator is 0.
So t is negative 1.
So when 4t plus 4 equals 0, or when t is negative 1. So that's cool. We found when. Guess what I'm going to ask you now? Where is this? Where is this? And that would be the location. When t is negative 1, what is the location? So that means plug in negative 1.
Alright, so 2 minus 3,
I think I get it. Negative 5.
negative 5.
Bless you. 26, I think.
Yeah.
XY.
Okay. All right. So we found that point. All right, now I'm going to ask you this. Why is that happening? I mean, the derivative is undefined.
Vertical tangent line.
Well, good. Back in Cal 1, back in Cal 1, derivatives were undefined, and we could analyze it. They were undefined at endpoints. If you ever had an endpoint, they were undefined. Sharp points,
Oh, yes.
they were undefined. Discontinuities like holes or vertical asymptotes, they're undefined at discontinuities. The fourth one is a vertical tangent line, which is not a vertical asymptote, but a vertical tangent line. So I'm not sure which one it is. I'm kind of thinking it could be a vertical tangent line. I'm not sure yet. Let's sketch a graph, finally. So now, can you pick up your calculator and see this? But by the way, here's what you should see. I'm going to show you what you should see. Where's these points? Negative 5, 26. That's an important point. Negative 5, 26. That's an important point. Where's my other important points? 9.9, 7.6. 9.9 and 7.6. You guys with me? Well, I'm just plotting all these important points that we found. We found these important points. These were where we had horizontal tangent lines, remember? That's what these were. Negative 3.9, 28.4. Negative 3.9, 28.4. That's interesting. That's a good one right there. So that's supposed to be a horizontal tangent line. That's supposed to be a horizontal tangent line. This might be a sharp point, or maybe it's a vertical tangent line. Like, you know what I mean, you guys? Anyway, I want to see the graph. So I'm going to pick up my calculator and try to see it. If I hit this picture perfect, you guys get to go home early.
Okay. All right.
It ain't going to be perfect.
Okay.
So I got to go to parametric mode, type this dude in, try to set up a good window. Let's see what happens here. Y equals, clear that last thing, clear that last thing. I'm typing in 2t squared plus 4t minus 3, 2t squared plus 4t minus 3. And then I'm typing in t cubed minus 9t plus 18. And I'm graphing, I'm not going to hit graph yet. First I'm going to go to my window. I think I want, what were the important t's I found? Negative square root of 3, square root of 3, negative 1. Yeah, so I don't know, maybe I'm going to say negative 5 to 5 might be enough t's for me. I got a nice small t step. You know, based on those numbers I got on the board, what would be good x window? I'm going to say negative 15 to 15. That's what I'm going to say. And what about a good y window? 0 to 30, she said. I'm going to just say negative 10 to 30, just to give me a little more wiggle room there. You guys with me on these ideas? I'm going to hit graph now, and I might have a pretty good looking graph. Dude.
All right, hold on.
Dude.
Well, I'll see you Monday.
Dude! We ain't bad. Can you see? We need more lights off. I'm proud of that. Oh, there you go, lights, come on. Emergency lights. Anyway, we found two places where we had a horizontal tangent, and by the way, there's one of them. You see it? I mean, right there, there's a horizontal tangent right there. And where was that? That was t equals, which one was that? That was negative square root of 3. That was t equals negative 1.7. That's negative square root of 3. And then by the time t got to negative 1, where were you? By the time you got to negative 1, you were right here. And that's a little vertical tangent line right there. See it? I mean, the tangent line is vertical. And that's when t was -1. We found that guy. Where was he? Right? Remember this? T was -1. That was that guy. And then t went to 0, and I don't know where you were, but then when t finally got to positive square root of 3, we found that other horizontal tangent line, and I missed it a little bit here, but you guys see it? Where it's another horizontal tangent line right there, roughly. There's another place of horizontal tangency there. This is a cool, weird shape here. It's a parametric equation. I think it came traveling in like this. Do you agree? I think it came traveling in like this and then headed off this way. And I think we, by analyzing the derivative, I think we found all the interesting places. When does it have horizontal tangents? When does it have vertical tangents? Or, we found all the good places. After, before that, there's not much interesting. It's just coming up here. And after that, it's just going off forever, probably. So we kind of found the interesting places, and we set our window to look at those places. Yes?
Where did you pick the t -10 on the calculator?
I actually picked -5 for my t-min.
Yeah.
I picked -5 to 5.
Okay.
What was I thinking? What are my important t's? My important t's were plus and minus a square root of 3, which is plus and minus 1.7, and the other important t was -1. So I just thought I wanted to see some. So I set my t's between -5 and 5. I just wanted to see some of this graph. I just tried to get a range of t values to see. It's dangerous. Your calculator, I just want to show you one thing. If I go to Window and have this thing set from 0 to 5, sometimes by default, your calculator starts with a t-min of 0. If you start with a t-min of 0 and do this on a test, you're going to write down, you're missing half the graph. You're missing a big chunk of the graph if you just started at t equals 0. So be careful. So it's good to have some negative and positive t's, usually. All right, I finally quit. Thanks for working and thinking with me. I appreciate it. It's fun to play with these parametric equations. I don't know. I like this last problem. I like this problem. Your book doesn't really have problems exactly like this, I don't think. Maybe they have a little bit.